Hey guys, welcome back. In today's video, we're going to be diving into an exciting project. In the last couple of videos, we did sales forecasting. In this video, we'll be doing customer churn. These two goes eye in hand. You can, forecast what kind of customers or what kind of sales you're going to be having in the business. But it's also important to understand the customers that you're having in the business. How are you retaining them? Which customers have the tendency of leaving the business or going to another competitor product. Now, in our case, these particular products that we have are going to be a real use case. We have a data export from an e-commerce provider that has definitely provided us with some data in this case. This data has been anonymized and randomized as much as possible, so we don't identify any customer with it. In this case, let's get into the architecture of the system and see what the architecture of the system look like end to end. Now, we get started with this export. The export is going to be coming from Excel. Now, we have an Excel file that has been exported by an e-commerce provider and randomized and anonymized as much as possible to not expose any PII of any customers. So in our case, we have the Excel file. This can also be configured to be from Postgres or even read directly from S3. This can be done easily by Boto3 or by Alchemy if you have a connector with Postgres. Regardless of which one you decide to do, the simplest I believe is just to use the e-commerce dataset from Excel file, which is what we are trying to do in this video. Once we read that, we're going to use a project in our Airflow, which is our DAG. This particular DAG is going to be reading from this Excel file, and we are going to do data cleaning, feature engineering, machine learning trainings. We're going to be training two models in this video. One is logistic regression for forecasting, and we're going to be doing random forest as well. These two models will also be put head to head together, and we select the best model out of these two, regardless, because you might not, the same random forest may not be best suited for all these cases every time. Sometimes random logistic regression may be the best approach in this case. So we have a logic to intelligently switch between logistic regression and our random forest algorithm model that has just been trained. Based on this, we register that, and in MLFlow, we register this model and promote it to production. Now, until a certain threshold is met, I think about 70% or 75% of the threshold is met in terms of accuracy, ROC, AUC, accuracy. Once we do that and we are above 75%, we can promote this particular model to production. And this is going to be consistently done subsequently. If you train the model and the performance is really bad, it's not going to get promoted into production. And this is how the MLFlow and Airflow handshake happens. Once this is done, we have the model in production. We promote this to Streamlit, and in our Streamlit app, we can just infer in real time from this model that has been registered on MLFlow. Let's get into the system. I know this is something that is a little bit too much in theory. So let's get into the nitty-gritty and get in touch with how everything connects together and how we stitch everything together at the end of the day to form a useful app. To get started, the first thing you need to do is get Astro installed. You can go to astronomer.io/docs/astro CLI/install CLI. Once that is done, you can verify that in your terminal by typing Astro, and you should see some command and help in there. Now, let's get started with the project. So I'm going to start by creating a new project, and in this project, I'll call this project, just gonna move this in here and change this to churn prediction. Churn prediction. So you can choose to use the latest version of Python, but for safety reasons, I'll use 3.10. That's usually stable. Most libraries are compatible with it, so there's no issues with that. We'll use churn prediction as the name of the project, and if you prefer to create a Git repository, you can do that. I'll just create that. You can always do that later. All right. Once that is set up, wait for this to get bootstrap and the terminal set up properly. In here, I'll just touch main.py just to be able to increase the size of the text. I want to see, I think this is fine, and I'll remove this. All right. So once that is done, don't forget we just initialized or installed Astro in our local system. So we can just type in Astro to confirm that it's properly installed. So when you see something like this, you see Astro CLI, then it is properly installed in your local system. Now, if you are using Windows, Mac, or any other Linux distributions, you should be able to install this fairly quickly using the instructions on the page. All right. Now, I'll start with Astro Dev init. So to initialize Apache Airflow in this root directory. So I'll say yes, initialize the project here, and you can see all the Dags and the folders and the configuration settings are properly set up for me. Good. Now, so that's the first step. The second step is to now go in here and start up Astro. So you want to quickly start it up to be able to envisage if there's any issues or whatever. This is a bootstrap project, so it's not going to be a problem. So you can say Astro dev start, and then this is going to download the images into your local system and start up Apache Airflow running locally on your local system. So waiting for this to be built, and we can get started. Okay, so the project is started up, and you can see what this looks like. This is using Airflow 3.0, so you can see the DAG example astronauts. So you can trigger this, but obviously we know this is going to work, so we don't need this. So I can delete the example DAG in here, and we can be rid of that. Alternatively, you can decide to just rename the content and just get things working by yourself. But all well and good, we're good to go with this. Now, the first thing we need to do once this is properly set up and we are ready to crack on is to first get the Docker override in place so we can set up our MLFlow, because we'll be training some models as discussed earlier. So we'll be training the model, so we need Apache MLFlow in here and some other services that will help us facilitate the training. So let's kick into that. So if I go in here and do touch docker compose.override.yaml. Now in this override, I'm going to start with the MLFlow, which is the service that will be storing our model training and artifacts and the statistics. So I'm just going to have services in here, and I'm going to have MLFlow. Image is going to be from Python 3.11 if you prefer. Python 3.11. I'll use the slim version, right? And then the platform is going to be Linux ARM64, not AMD. The environment is going to be, I've just used git python refresh. It's going to be quiet. All right. So the command to start our MLFlow service is going to be, just going to put this here, and I'm going to have bash. All right. Pip install MLFlow. You don't necessarily have to specify the version for pip install for MLFlow, but just for simplicity's sake and for safety reasons, I'll do that. So otherwise, if you are installing the latest version of MLFlow, let's say 3 point something, and some services are no longer supported, then probably some of this project parts may not work. So I'm going to have scicop G2 binary, scicop G2 binary. Then I'll install Boto3 just in case we want to store our artifacts inside of min.io. But essentially, I guess that's all we need to do in here. So let's make a directory, md make directory -p MLFlow artifacts. This is where we're going to be storing all the artifacts. So then we do a gmod 777 MLFlow artifacts. Then we can start our MLFlow server. As simple as that. MLFlow server, the host is going to be 0.0.0.0, and the port in this case is going to be 5000. Let's get our backend URI stored in here. So it's going to be backend store URI, which is done. We change this to MLFlow. All right, and MLFlow DB. Yeah, and the default artifact root directory is going to be the artifact default artifact root. Okay, this is going to be a file, and I'll put this inside of MLFlow artifacts. And I think with that we should be ready to crack on. Wait, let's see one more thing. Let's serve artifact. All right, and I think that should be all we need to do. Let me see. MLFlow. All right. Yeah, let's just break this down a little bit. Okay, good. That looks okay. And the volumes is gonna be MLFlow artifact in here, and then the ports. Let's get the ports in where we expose our MLFlow. So we're exposing it on 5001, and it's gonna be 5001. Let's wrap this inside of single quotes. All right, so it depends on, it's going to be MLFlow DB, because we need to get the DB inside as well. Essentially, finally we have the networks. It's going to be Airflow and default. So by default, when you start Astro, it comes with a default networks because it's already packaged. So we just need to leverage that particular network. All right. So just put unless you stop it, then it should stop. Now that's our MLFlow. So let's set up with the DB. It's going to be a Postgres anyway. So it's going to be Postgres 16 Alpine. We're not interested in the full version. So Linux ARM64. The environment is going to be, let's get MLFlow as the user. The password is going to be MLFlow as well. The Postgres DB is going to be MLFlow. All right. So the volumes in our case is going to be MLFlow DB volume, and that will be that. Then the health check is going to be, let's have a test in here. CMD shell, just remove this CMD. All right, PG is ready. The user is MLFlow. Okay, and that's it. So the interval is 5 seconds. The retry is 5 seconds. 5 interval retry. Then we have our networks. It's going to be Airflow and the default. That's fine. Then restart unless stop. Good. Now let's get in our volumes and we're good to go. So volumes are going to be MLFlow DB volume, MLFlow artifacts, and networks in this case is going to be Airflow will be external, which is going to be true, and the default is going to be false. Is it? Let's get our name in here. So if you take a look at your Docker dashboard, you see that you have a name, Churn prediction 4031_AC. So I'm just going to use that. So I'll say Churn prediction, is it _4031AC. Yeah, so that's the network. So we just have a default after this, and in here I'll put a name to it as well as Airflow. And the reason is because we want to connect to the Airflow network that is set up by Astronomer. So in this case, make sure the name matches your project name. In this case, Churn prediction _4031_AC_Airflow and default. And that's all you need to do. So you just need to start again, and then MLFlow and the DB will both be started. And you can see in here we have our MLFlow in here, which is getting started. The DB is there. Our MLFlow is also getting started, let's see what's the issue in here. So it's saying could not find a value, a version that says, okay, scicop G2 binary. All right, it's picop. I type in picop, isn't it? Say scicop G2 binary. So that should get it fixed. The project is starting up and it should be started now. Okay, so let's check again. So apparently I'm still this is scicop, not scicop. Why do I keep making that mistake? Scicop G2 binary. Okay, so should be started now. Now our MLFlow is here. We're good to go. So all the installations are in place and currently running, which is good. So that means our installations and setup is fine. So we can get started with the rest of the system. Now let's create our pipeline for training the model. So I'm just going to create in here, and I'll call this Churn pipeline.py. All right. Now, before we start writing any code, we want to make sure that the data that we're going to be using is properly situated in the system. So I'm going to just paste the data set in here. And this is the data set we're going to be working with. So if I show you what this looks like, I'm going to open this in Finder, or rather I'll just open this with associated application, then Excel should start up. Now you see what this data set looks like. So this is a real life data extracted from a particular company. So here we have some columns which are the variables and their descriptions. You can see the data set is e-commerce. These are the variables that we're going to be working with. So this is the unique customer ID. When you see churn, then this particular customer has actually churned. The tenure is the tenure of the customer in the organization, and the rest of the information keeps going. Now this is what the data set look like. Yeah, in actual sense, this has been redacted in some form because there's no information about the customer, let's say the first name or last name or stuff like that, but we have the customer ID, which is a good use case. So we are not really exposing any PII in here. So the customer ID is here. Some customers have churned. We can check this against the rest of the columns. So this is what we need to look at. So if you are familiar with machine learning and how it works, you probably know that when you're starting to predict a particular data set, or you want to predict the outcome of these variables, you want to make sure that this particular outcome that you currently have is removed from the data set. You can verify the output of the model once you are done by comparing what you had initially against what the model output is, or you check the accuracy of the model after you trained it. But regardless, what this means is if your model is saying this customer is going to churn, then based on that, you can be able to predict why this customer might churn in the future, and it's going to give you a percentage confidence as well, so which is good. So let's get into the core meat of the system and see what that look like. All right, so if you go back in here, so this is what our data set look like. So we can just close it up and let's get started with that. So the first thing we want to do is get in our imports. So let's say import sys, and we're going to say sys.path.insert. It's going to be user local airflow Dags. All right. So this is what we need in here, and just to make sure that we are resetting the directory to the right location, so when we are reading from it, let's say files and all that, it reads properly. All right, so from airflow dot decorators import task and dag. So this is scribbling because we don't have Airflow installed, Apache Airflow. So if you install that, then this IntelliSense errors will go away. All right, now so from pendulum, let's get in our date time. From pendulum, import date time. So that should be fine, and we're going to be needing pandas as well. If you prefer, you can use any other libraries that you are comfortable with. There are some other drop-in replacement for pandas which works fine as well. So from typing import date, we're going to be needing this and any. Let's get our login in place as well. That's all. So let's get our DAG in. Our DAG is going to look like this. So the start date is going to be date time. We need to install pendulum. Pip install pendulum, isn't it? Pip install. So 2025. The month is 11 and today is 8. All right. So the schedule is going to be weekly. You can change this to daily if you prefer. Catch up is going to be false. Then the tags, this is not necessary, but it's just to make things more readable and descriptive. All right. Churn, prediction, and let's say e-commerce. All right. So the description of this DAG, the description, if I can only type description, it's going to be production customer churn prediction pipeline with ML features. All right, good, and that's it. So we can get started with this. So we can say our initial pipeline is going to be dev churn prediction pipeline. All right, so the first thing is to load for the first task. We want to load the data from our Excel file. All right, so the task in here is going to be let's call this load e-commerce data. All right, and we don't need a path in here, so it's going to be just empty, and in fact we don't need this. All right, so loading data from, we don't need that, so that's really unnecessary. We have our Excel path. It's going to be our e-commerce data set, so it's going to be in user local airflow Dags, but not in Dags. It should be in data, isn't it? And we have e-commerce data set .xlsx. all right, so that's our Excel part. The sheet name that we need to work with is ecom, if you can still recall. Just to juggle your memory, I'm going to open this in Associated Finder application, and you can see that we have ecom as the worksheet we want to be working with, not the data dictionary. All right, so we have ecom, and then login.info is going to be just to write something to specify what we're trying to do. All right, so loading data from this Excel path, so we can say df is going to be read Excel, the sheet name. All right, so login.info, we're going to have loaded with, let's get a shape, with shape df.shape. Good. Now the columns, info columns, is going to be df.column. So let's change it to list. Okay, good. All right, so that looks okay. Now let's accept this. Login the error loading data. Okay, good. Now we've read, hypothetically we've read the file. We logged the shape of the file, the columns involved in the file, and then we can say let's clean the data. So df is going to be clean and impute data. And this is what you want to do. Usually the first thing you want to do is to clean the data set and impute the respective data that will be used. All right, so I'll just create a function in here. I'll call this dev clean and impute data. All right, we're going to be needing df, which is going to be pd.dataframe. All right, so we get numpy in place. Import numpy as np. It looks like we need to install numpy. All right, so numpy in there. So we say initial rows is going to be length of our data frame. Then login.info, we say starting data cleaning for these rows. So we say let's get our missing summary. It's going to be df.isNull.sum. So we get the total null values in this data set, then the null percentage, and this is going to be very useful when we want to get the percentage and see how we can impute the data, whether it's, so if you have high imbalance and a lot of data is null, that may not be useful. But if it is let's say 2% or 1% is null value, then you can impute with some strategy in this case. All right, so I'm just going to close this out, then round it into 2 decimal places. All right, yeah, that's fine. Multiply by 100, round 2. Okay, good. Now for the column inside of df, in fact, should we use df directly? So let's say missing summary, and let's get the missing summary index. All right, so if okay, so we have the missing summary is greater than 0, that's fine. Let's just log something in here. Login.info, we are saying column as missing this percentage. All right, now the first thing we want to do is remove the churn column. All right, so if churn, this particular column, we want to remove it because it's not going to be useful when we are trying to do our prediction. So it's not a variable, it's a target output. Yeah, so we don't need this. So we say if churn is in df.columns, then let's remove it. Df equals to df.drop, we drop the column. All right, so we say df.drop, and then we can use a subset. I prefer subset in this case. Subset is going to be churn. All right, good. Now let's remove that. It's a target variable, so that's number one thing we need to do. We say remove rows where target variable, is it rows? It should be column, innit? Remove column for target variable. All right, that's fine. Then number 2, the next transformation we want to do is handle id columns. So we should remove the duplicates but keep the data. All right. So if there's a duplicate in customer ID, we want to remove the duplicated columns. So we say df is going to be, let's even get the duplicated IDs first. Duplicate IDs is going to be df.duplicates, the subset, and then we keep the first one. All right. So let's get the sum of all of them. How many records do we have? So if the duplicate IDs is greater than 0, then let's remove them. Okay. So df is going to be duplicates. The subset is customer ID, and we keep the first column, the first record that exists. So we say dropped. Yeah, that's fine. Now that is number 2. Number 3, we now have our numerical imputation strategies that we want to apply. Now this is now left to you based on the data set you're working with, but in my case, let's get this instead. Numerical imputation strategies. Yeah, so let's get our numerical columns. All right, so we said select types, which is including the numbers, the columns, then to list. Let's convert it to list. Now we say again, if there is churn in the numerical columns, then let's remove it. All right. Otherwise, for each of the columns, let's see what we have. Yeah, so for each of the numerical columns, let's get this. If df, the column name, yeah, if the column is null and the sum is greater than 0, so that means we have more than one column that is null. In this case, then if the column is in tenure, you can check it out, tenure order count. In fact, I'll just put this side by side so I don't make a mistake. If it is in tenure order count, I'm just going to order count. Coupon used, I'm just remove this, I'll minimize it. Coupon used, and number of device registered. Okay, if any of the columns is including that, we are going to be using the median. We use median for counts like variables. All right, and that would mean a df column fill na medium. So if you have any column that is inside of any of these 4, we use the median because they are usually count. Yeah, otherwise, if it is not any of those 4 columns, so let's say elif column inside of satisfact, to avoid typo error, satisfaction score. All right, so for satisfaction score, we're going to be using mode in this case. So for the imputation, so we use not mode, we use the mean. Well, not mean, we use the mode rather. Yeah, if yeah, this is wrong. If dot mode dot empty, else we use 3. Let's see, else use 3. Okay, so we are saying if it is a satisfaction score, and satisfaction score looks like this. Satisfaction score, so you have 3, 2 and the rest like that. So you see 1, 2, 3, 4, 5. So we are trying to use the median in this case. So even if we are using whatever mode or median, it doesn't matter. What matters is we are imputing this correctly. So the safest is to just say more like indifferent when you are imputing something like satisfaction score. So we are saying if the mode the first record in there is empty, then use 3, otherwise use that particular mode record. All right, so we're saying fill NA. I'm just going to move this away from here, and that should fix it. Okay, good. Now so that's for our satisfaction score. Otherwise, if the column is in cashback amount, let's see what that look like. Cashback amount. All right, or we have, let's see, other amount, hike from last year. We use 0 in this case. Use 0 for mandatory values. This is assuming 0 means no cashback. And the reason is because when you check the cashback value, we have a couple of records in here. So when you see 0, the assumption is there is no cashback. But if you see any record, then there's a cashback value. All right, or no hike. So in our case, we fill NA with 0. Then let's get more into the picture. If the column name is inside of day since last order, then we use median. In this case, use median, but we cap it at median, but cap this at a reasonable value. All right, so the median in our case is going to be the column name median, and then we cap it. So let's say median, we cap it at fill NA if the median is less than 10, otherwise 10. All right. Alternatively, you can just use median directly and you're good to go. So either way works for me. It's just to be able to fill the data correctly as expected. All right, so any other columns, we just default to median. Let's default to any other columns. All right, median for everything else. Okay, good. Now I know this is a long show, but let's quickly recap what we did in here. We're saying if the column name is in tenure, order count, coupon use, or number of devices registered, we use median for that. If it is satisfaction score, we use this the mode. We are using mode in here. All right, so if it is cashback amount or other amounts hike from last year, we use monetary value as 0. If it is days since last order, we use median. Any other thing is median. But if you send something in here, we're kind of repeating some logic in here. So essentially, we don't necessarily need this and this, but I'll leave it as it is. Okay. All right. So that's our numerical. I'll just change this to say imputed numerical. Good. I'll leave that as it is. All right. Now, so that's our first one, our numerical imputation strategy. Now let's get our categorical columns imputation strategy. So the number 4 is going to be to get our categorical columns. So we did that by saying select the types of objects, which is usually the way you get the numbers that are not numerical, the columns that are not numerical. And we're saying, let's change this. If customer ID in categorical columns, let's remove the customer ID. All right, so we're not needing that. Then we say for column in categorical columns, if the column name, if df call is null, the sum is greater than 0. Then we now need to identify some categorical columns that we want to use, just like we did for the numerical columns. So we start with the column in preferred payment mode or preferred login type. Let's see what that look like. Preferred payment mode, preferred login device, and preferred order category. Okay. Then we use mode for those ones because they are like preference columns, so we just use mode for our imputation strategy. So we say use mode for preference columns, and the mode value is going to be df. Yeah, mode. Let's see, we're saying use mode if column. Nah, that's wrong. So we say if not df call empty s or no, that's fine. And then we say df column for this particular column, we are filling that with the mode value, any a value in there, so that's fine. Now elif, if the column name is in gender or marital status, we're using mode for this. Then mode graphic columns. All right, then we df. Yeah, that's fine. Any other thing, we use mode. Essentially what we're doing is to use mode for this, but we just want to make sure we take care of individual columns, if you get what I mean. So we say default to mode for everything else. All right, good. I suppose our categorical column imputation is complete. Now let's do the final cleanup. I'll say final cleanup. After all the imputations are done, we only drop rows if they still have critical missing data, and check for any other ones. So check for any remaining values in critical columns. All right, so our critical columns would be churn, tenure, and satisfaction score in it. All right, so those are our critical columns. So if any of these critical columns are missing, so we say df critical missing. Yeah, we get that. So if we have any of these critical missing, then we need to drop them. All right, so before critical drop is going to be length of df, and df is going to be drop the column, and then login.info. Yeah, that's fine. Now this should be number 5, isn't it? Number 5. And number 6, before we continue, we say data validation and maybe cleaning. All right, so these are just for outliers. So these are for outliers. All right, so our outlier column is going to be, I'm going to remove this and call this tenure cashback order count. All right, So for the column in outlier columns, if the column name is inside of, let's get Q1, it's going to be quantile 25, Q3 is quantile 75, and IQR is going to be Q3 minus Q1, and then we can get our lower and our upper bound is going to be lower bound is going to be Q1 minus 3 multiplied by IQR. So we're using, so just to comment this out, we're using 3 times IQR in here to have a less aggressive outlier removal. All right, for less aggressive outlier remover. All right, and the upper bound is going to be Q3 plus that. That's fine. Now anything outside of this, we try to remove them. All right, so we say our DF, let's remove this, outliers is going to be DF column in lower bound or DF column in upper bound. So we get that. So if our outliers are greater than 0, we say yeah, that's fine, and then we remove. So what we're trying to say is we specify the upper and lower bound. Yeah, so 3QR is like 3 times 0.25, so we go less than that in our lower bound and the upper bound. So we specify a new bound for what the data will look like. Anything outside of this are considered outliers, so we can remove them to avoid issues and imbalance in our data set. So our final rows is going to be this. Our retention rate is going to be that in percentage. Then we can just say data imputation complete, retention rate is that, and that's it. We can just return DF. All right, so that's all we need to do for our cleaning and imputation of data. Now once that is done, we go back into where we came from. After this data is cleaned and imputed, so we have our final rows. Our final rows is going to be length of DF. So we can say data imputation complete. These are the final rows that remain after the cleaning is done. All right, now ensure in here that the churn column exists and is properly formatted, because this is going to be very useful for us. Ensure churn column exists and properly formatted. All right, so churn is going to be 0 or 1 essentially. So we say churn is going to be df as type integer, not boolean. Churn rate as a now is going to be the mean, and then we say login.info data set loaded, and we have churn rates. Good. Else we say login.info no churn column found in dataset. All right, and then we return error, no churn column found in dataset. Good. Yeah, that's fine. Now let's convert into a serializable format so we can properly serialize it. We say our data is data.toDictionary, and we orient the records. The number of customers is going to be length of DF, and the churn rate is going to be that. Let's convert this to float. Okay, good. All right, I suppose that's it really. Let's raise an error in here and call this runtime error. Failed to load data. All right, so that's our first task, and right now it looks like we are rocking and rolling. Good. Now once we simplify this, our first task is properly done. We can minimize that. The next one, is there an error in here? All right, missing percentage is that, so it looks like you're not using. Yeah, that's fine. I suppose we are okay with that. Okay, now the next one is going to be to validate.